Our second example on putting everything together is going to be this y equals x squared over x squared minus 16. So again, let's just pop over to my work here. X squared and x squared, so that's an even function. So when we're graphing this, that means on the left side of the function is going to match perfectly to the right side of the function. So that's kind of a neat property to have. We're going to talk about slopes, where they're positive slopes with the negative slopes. We're going to talk about where it's concave up, concave down, and we're talking about asymptotes. And because this is a rational function, we're going to talk about horizontal and vertical asymptotes. All right, first derivative. Well, it's a quotient, so we did the quotient rule, did some common factoring, simplifying, and we get this negative 32x and x squared minus 16 squared on the bottom. So what makes the top equal 0? It's equal 0 when x is 0. What makes the bottom equal 0? It equals 0 when you're at plus or minus 4. And that matches your domain, right? So if you look at your function, it's all real numbers except for plus or minus 4. We've got slopes everywhere except for a plus and minus 4. So we do a table with our critical numbers from negative infinity to negative 4, negative 4 to 0, 0 to 4, and then 4 to infinity. I have to be aware that this negative sign has an impact on my column. So I don't need the 32, but I do need the negative sign to go with my x. And this denominator, x squared minus 16 squared, it's whether you factor it out, whether you leave it as x squared minus 16 squared, is always going to be positive. It doesn't matter what you put in here, except for the 4's, right, which is fine, but you didn't put the 4's into your rows. It's always going to be positive. So what kind of slopes do you have? Well, your function's increasing in the first two regions, and it's decreasing in the next two regions. You only have one place, though, where you actually have a local maximum or local minimum. In this case, you're going from an increase to a decrease, so you've got a local maximum at f of 0. And that kind of makes sense as well, because we've talked about being an even function. So your maximum makes sense that it's going to be right on the axis then. Find a second derivative. So again, we have a quotient. We're just going to use the quotient rule again. Do all your work, simplify, put f and g of whatever you need to do. A little bit of factoring, right? I did some underlining here. Negative 32 is going to factor out. X squared minus 16 factors out. And then what's kind of left behind, and you clean things up. A whole bunch of negatives happening in here. So again, you take the negative out, it becomes positive 32, 3x squared plus 16, x squared minus 16 cubed. Sorry about that. So we, again, you know what, there's just tons of algebra to go through here. So that's like a good chapter 2 review of how to do the quotient rule and some of your factoring skills. What we need to recognize again is, where is my second derivative 0? Where is my second derivative undefined? So what makes the top of the function equal 0? Nothing. You can't put anything in here and make it equal 0, because the numerator is always going to be positive. What makes the bottom equal 0? Well, go figure that the exact same critical numbers that where you didn't have a slope are the same two places where you don't actually have any concavity, and the same two places where you don't actually have any points. So you can't be concave up, concave down. You can't be increasing or decreasing if the function doesn't exist there. So when we look at my second derivative, really we're just talking about what's happening outside of the 4's or what's happening inside the 4's. And I didn't do a table because I just want to talk about how you can do the algebra here. Outside the 4's, so it's like 5 or negative 5, 10 or negative 10. It doesn't matter which one you pick. If you pick 5 squared minus 16, it's a positive number. If you put negative 5 squared minus 16, it's a positive number. And a positive cubed is a positive. And we know the top is positive. So outside of the 4's, your second derivative is going to be positive. Outside the 4's, your concave up. Between the 4's, if you put 2 in here or 3 in here, right? 2 squared is 4 minus 16. 3 squared is 9 minus 16. That's negative between the 4's. So you're concave down between the 4's. If we're talking about vertical asymptotes, again, you actually have the answer right here. X equals plus or minus 4. You have the answer right here. X equals plus or minus 4, because that's where you're causing divided by 0. So those are our vertical asymptotes. If I go right back to the start of my question, x squared and x squared minus 16, if you did the work equals here, you'd get y equals 1 is your horizontal asymptote, again, because you'd factor 1 over x squared, 1 over x squared, right? So y equals 1 is your horizontal asymptote. So if I put all that information together then, we talked about the functions increasing from -4 to infinity, and the function's increasing from -4 to 0. So there's your increasing, but not increasing where x equals 4. We said the function's decreasing from 0 to 4. The function's decreasing from 4 to infinity. All right, so that matches. We talked about concavity. It's positive, so it's concave up outside the 4. So again, your tangents are underneath the curve here. Your tangents are underneath the curve here. So it's concave up. Concave down between the 4s, right? All your tangents are above the function within this region, it's pushing it down. So it's concave down here. Now, I didn't draw the line in, I guess. Should have drawn the line in for our horizontal asymptote. So if I drew the line in here, that would be a horizontal asymptote of we said was y equals 1. Make that a nice little color for us. Let's go purple. All right, so that's y equals 1. So as we approach infinity, we're approaching the value of 1. It's getting closer and closer to 1. And the vertical asymptotes, same thing. I didn't put those in, but we could put those in real quick. And again, this is all about where we were dividing by 0, whether it was domain dividing by 0 or whether it was where the function has no slope. But there's where your asymptotes are. Okay, so these are two great examples that really put together all your thoughts about functions. All right, time to get some work done.